Hi guys, today we are back with a new video for our AI agents playlist that we are started on the YouTube channel. So in the today's video we're gonna discuss about different topics as part of our AI in STLC that we are covering. So today we're gonna be covering about three core concepts which are around context engineering, agent harnesses, and graph engineering. You might have heard about these terms here and there and try to understand in different concepts in different scenarios. So we will discuss about these concepts today and see how those flows in whenever you are working on any of these tools like Cloud Code, Cursor, etc. How to use these features inbuilt, or let's say build some features considering these practices in mind. How to do this? That's the agenda for today. Without further ado, let's get started with the video. So, what is context engineering? Context engineering is pretty simple to understand. For example, you have a context. Context means it's kind of an information, it is a kind of data that can be injected or that can be taken out at any point of time or loaded wherever needed. So, for example, you want to work on a AI agents use case. Let's say you are working on a banking loan application, so in that loan application, somebody fills up the loan form and then you basically extract the information of that user from the external sources. What is the user's CIBIL score? And then it basically goes to the next step, which is approval stage and all that stuff. Now, in all the steps, like when you submit the form at the first of all, the CIBIL score is fetched. So CIBIL score is fetched when it is needed. So that is actually a context, or that is actually a data which is needed at that specific step. Now after it goes to the approval stage, so it verifies your again CIBIL score and the information that you have entered, whether it is aligned to your ID proofs or not. That's again, ID proofs are your context at that time which is needed as well. It might be needed in the first step also, but it is needed at that step for verification. That's where these are the data items, or these are the context items which are needed by the agentic systems in different steps in the entire workflow. So whenever you need different type of data, that is context, that is loaded at that specific step only, that is the known as context engineering. Why it is important? Let's look at it. Let's first understand from the lens of Claude Code, Cursor kind of tools, what is context and what is actually called context in that sense, and how those are loaded. So as you can see here in this diagram, so there are tool definitions, there are system instructions, user queries, and conversation history, retrieved knowledge. So as you can see, if you have seen the tools like GitHub Copilot, Codex, Cursor, Claude Code, Anti-Gravity, or any others like this, so you might be able to understand the term like tools or functions or MCPs. So these are the functions which you can basically execute at any point of time in your execution. Now, those are the functions that can be that can run, and those are having some body, those are having some descriptions, but those are loaded upfront whenever you start a chat. Only the definition is loaded, which means what the function is expecting, what is the schema, and what is the output, and what does that function do. That is the only thing which is loaded. Now as many functions you keep on adding, as many tools you keep on adding, those actually keep on adding in your context when you start the first chat. So it means if you have hundreds of tools available, if you are loading the definitions of all those 100 tools, no matter if you need all of them at that very instant or not, so it will still take in your context. That's the tools and the functions part. And same goes on with the other things like rules, your agents files, your constraints, your any other documents. So everything gets put in into the context when you load it at the first. So then it is having a user query, then it is having a task, what user is asking for. Then if you want to load the prior history or not, like whichever agent has learned in the previous exchanges, whether you want to load that as well, that also goes into the context history. then any other documents you want to retrieve before the AI gets start with the calculation or something. That's what you want to load these things or not. Now, some of the things you may feel that you may need at the start. For example, system instructions, user query. These are must needed for a initial task. Conversation history also, yes. In bits and pieces you might need. Like for example, you have 10 conversation histories in your let's say history database of anywhere. You may not want to load all of them. You may want to load only the main which is actually used across all the use cases which a customer may have. So that's where the conversation history is dependent. And secondly, retrieve knowledge, whatever you learned in the past, whatever you want to retrieve from there. So that's what is actually a retrieve knowledge. So these everything which you are extracting and putting it in the first message, those are starting with the context, and all those things goes into your context window to the LLM. Now, based on your workflow, as I mentioned at the start, if you are having a loan management application, you may not need entire context upfront. You may need some context in your workflow, like as I was explaining the workflow in the last video, where you were having a SDLC pipeline, and each of the step may need different kind of context or information. That's what is the loan application is resonated to. So loan application also will have a workflow, and each of the workflow or each of the agent or a step may need different information of data for that specific use case. That's where we have to reliably, and we have to think in from the customer perspective, that what data is critical and when it should load. That's what is about context engineering. And once you send that data into the context window, so it goes to the models. Model basically generates an output, or it basically triggers a tool, or it says that I want to trigger a tool call or something. Then your agent will, like Claude Code or something, it triggers a tool and gets the output, and that feeds back to the context assembly. That's what is about the context engineering. Now we'll move to the next part, which is why context engineering is hard. As you can see, the context window talks about the how much an LLM can actually read and understand. For example, different LLM models that we have available today, they have different finite context window. So some models may have 100,000 token context window, and some may have 200,000, and some may have only 50,000 token context window. So the LLM, to respond LLM in a reliable way, we'll have to give it to the right data, which is inside its context window limits as well, to get the right data out. So for example, garbage in, garbage out, the simple term. So if you give it more data, doesn't mean that it will give you the right output. But if you give it less but quality data, it is more necessarily will produce the right output. That's what is about context engineering, why it is important. So you have a token budget pressure, you have a signal to voice, which is garbage in, garbage out. So you don't want to put in everything and and you expect the right output. And at the same time, you don't want to put everything, and the meaningful data should not be hidden behind the token context window. Then whichever extra tool definitions you have, which let's say you don't need actually for the first task or the first step, so you are sending them, but those are actually blotting your token context window. Then your latency, as you make the context window larger, you send more data, it will actually get more costly, and at the same time latency will also be increased. So that's about these 4 points, and then about the context staleness and the multi-turn stale drift. So, for example, you are loading some past conversations or some history documentations by referring to some knowledge base. So that data source is getting stale, then the context which you are injecting from those sources will also get stale. So, which means you will have to reliably fetch the information from those contexts such that you fetch the latest information always, which is needed for that specific execution. and then multi-turn state drift. So basically, if you are doing uh, different conversations in the same context window and you are asking same questions again and again, so the each turn which you are going to LLM and getting the output, so they are basically taking the in output and increasing your context window, which may inflate and make your context window a bit tough to manage. So that's where this these are the points why context window or context engineering is very hard. Now, how it looks like in a Claude code or a cursor context. Let's say these are the context sources. You have a code base index, you have open files, you have rules, you have tools outputs, get definitions, get differences or history, user instructions. All these goes inside the context assembly layer. So then it does the compression and all that stuff, and then it goes to the Claude code, and Claude code goes to the and it calls the required AI model, which is LLM or something, and then it does the necessary action. All those necessary actions are responded back to the context assembly as well. So this is what we have explained already. So now we'll move to the agent harness. So agent harness is again a very important concept. So agent harness is basically which sits around the model. So context is what you have to load the relevant data at the relevant time. Okay, so if you want to fetch the relevant data at the, let's say I want to execute I want to get some data from a knowledge base, you should be able to get the data at the right time. Now, what is agent harness? So, harness is basically will tell you what to do and what to actually follow and how your harness should actually react to it, what to do when an execution happens. What is the next step ideally? So, for example, you ask it to develop a feature, ask the Claude Code cursor to develop a feature. Now, there is a standard workflow that you have implied, specification, requirements, planning, and then development, testing, and then ultimately releasing it to raising a PR or merging it, or then basically releasing it for the production deployment. Like these are the steps. Now, whatever agent harness is doing now, whatever let's say Claude code is doing, it is actually loading your context which you have asked at the relevant time. That's the first point, which is context engineering. Then once your Claude code ask it to, let's say, have you done this step, it will actually say that yes, I'm still doing it. So now the second step is context engineering was loading the right content at the right time. Agent harness is basically completing the entire loop in autonomous way. So, for example, if an LLM says that I want to call this tool, so your agent harness has to detect whether it's safe to call this tool, whether you need a permission or not. If you need a permission, if you are approved, then go ahead and execute in sandbox or in local environment. Once the results are uh, gathered, take it back, truncate it based on the solution or the results that have come, and inject only the relevant data from those tools or the outputs into the next iteration that you have, right? So basically, first thing is you are loading the context, right context at right time, that is context engineering. Second thing is you are loading or you are optimizing your entire processes is in an automated way, in such a process where you have policies and quality guardrails as well in place, in an autonomous or with human in the loop as well, so that that entire context runs in an autonomous way. So these concepts are very closely related, but they have a very minor line in differences. So this is about the harnessing concept. So then comes the graph engineering. Graph engineering is nothing different. So it's the extension of what we have discussed in these two concepts. Graph engineering says if you have to run a big process in an autonomous way, you not only need the policies, right context at the right time, but you need when and when you should say that your entire process is successful. So, for example, in this image, as you see, so you have first of all planning, then you do the retrieve context, then you do the action or implementation, and then you do the verification. If in the verification tests are failing, it will go back and readjust the test cases, execute it again, then go back in. So this is what is the graph engineering, which will tell that each step what it has to do, it should complete first by going back and forth communications and come back and improve it and complete it in the end. Whereas in the context or harness engineering, what we have discussed till now is it should load the relevant data at relevant time, and it should have the policy or the guardrails around which it should work. And at the same time, last but not the least is agents have a goal. They should try and complete that, staying in the graph format and coming back to that workflow again and again until that entire loop is completed. This is nothing but a you wanna call it loop engineering, graph engineering, workflow engineering, whatever. So there are different names available online. Now, this is all these concepts why they are important. In the last video, when we discussed about this AI SDLC pipeline, you can run that pipeline via human in the loop as well. Like each of the step, a human can approve and say yes, go, 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 and so on. The steps, all the steps are completed. But when you have to do this in an autonomous way, there are different things you will have to manage as well. For example, the cost. How much is the cost consumption when you run this in an autonomous way? Second, how much is the security and the policy and the guardrails are effective, and how they will run and when they will be effective? That's the second point. Third thing is whatever goal I'm expecting, whether it will complete or not. These are the three main questions that has to be answered when you are designing the autonomous AI SDLC flows. Now, these are not the only stuff. Once you set this up, you have to evaluate them as well. Because as and when you are changing your any of your artifacts, let's say agents, skills, tools, you need to reevaluate your entire process, whether it is in line to produce the reliable outputs. That's where your evaluation harnesses also comes in play. That we will discuss in the next video. But for now, this is the content that I wanted to share before we move forward in our upcoming videos. So it was very important to walk you through about these concepts. Once we have the understanding of these concepts, it will be easy for all of us to move forward in the upcoming concepts. So thanks a lot for your time. Hope you like the content and the video. If you do like our content, please do subscribe to the channel and share across in your friend circle or something, so that it helps the channel also to grow, and at the same time we can share the knowledge across to different audiences. Thank you.